Just later. Today we're talking about angles and radian measures. So, remember with the graph, this is 0 degrees, and then we go counterclockwise. So, a corner is 90. All the way over, a straight line is 180. And the bottom is 270, because I add 90 to that. And where I end is also 360, because a complete rotation makes 360. So this one just wants me to sketch the graph of 240. 240 is between what two numbers that I wrote on the graph? Because I went through and labeled the angles on the graph. Remember, if we start here, then I go counterclockwise and each line is 90 degrees. You always start here.
Why do you do 0, 1, instead of just 360?
Because I started there, right? So I started with 0. I went 90, 180, 270, and then a complete circle is 360. So that's both. Yeah, it goes counterclockwise. Because I started here at 0, 90, 180, 270, and then I end with 360. Okay, so 240 is between which two? 180 and 270. So I'm just going to draw a line in here. And then I want to show which direction I curved to get there. And then I'm done with number 1. You always go counterclockwise. Yeah. Because I was showing which way I was rotating. Ambria, be quiet. It will unless, like number 3, you see how it's negative? So that's going to tell me to go the opposite direction. One thing I didn't say on this paper, but you need to know for the test, is quadrant numbers. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So what quadrant did I end in? Quadrant 3. Yeah. That's it. That's really it. There's different things, but it's not really hard today. Okay, so number 2 is 500. So I can keep spinning, right? I can keep spinning around. So if I started here, it's 0. This was 90, 180, 270. Back over here, I was at 360. If I add 90 to 360, it's 4... No. 360 plus 90. 360 plus 90. 450. I'm adding 90 to 360. Yeah, because I need to find... Because I can keep spinning around, so I want to figure out where 500 is. 180 plus 90... Oh, no, just kidding. 450 plus 90. Try. Okay. So 500 is going to be in between the 450 and the 540, right? What? I didn't go all the way back to 360 because I know my angle is 500, so I only needed to find the two numbers that were on either side of 500.
So would that be quadrant 6?
No. Good guess. Still gonna be quadrant 2. So for this one, when I draw my picture, I went around a complete circle and then I landed there. So the spiral thing shows me how many times I went around to get there. I'm not making this up. You should have done this one in geometry. Really? Oh, okay. It was the day after the school shooting too. Hello. Okay, so what quadrant is this one in? 2. So questions on number 2.
Do you have like really like see where blackboard is at?
You can kind of just guess. So like, I can draw something like this, and I wouldn't. Wait, hold. What 360? 360 is right here. Oh, like if I kept going around, 720. Yeah, I start from here, so I keep adding 90. So if I always start here at 0. Huh? Guys, I can't hear Stephanie. Okay. So on number 3, I'm gonna start here again. This is 0, right? I always start there. But because this one's negative, I'm working backwards. So this is gonna be stupid pen. Negative 90, negative 180, negative 270, negative 360. Because negative always means go the opposite direction. So negative 50 is in between what 2 numbers? 0 and negative 90. Okay? So this time I draw my curve going the opposite way. What? No, it's not 1. 4.
So it's always going to stay the same, doesn't matter if you're going backwards or forwards or something?
Yeah. So what the quadrant numbers always stay the same. The angles just determine which way I move, clockwise or counterclockwise. Questions there? Okay. Give you a few seconds to finish copying this down. As long as it's in the right box. Yeah, so I'm not like judging you perfectly to draw a 300-degree angle. I'm just making sure you know which box it belongs in. When you want to be... Trigonometry is used in engineering, like, yeah, architecture, that kind of engineering.
So you said you're
He's a computer software engineer. He doesn't use this kind, but he used more of the, why am I forgetting? He does more of like, with his programming, he does like equations and stuff like that. So he does, what do you think? I like to joke that I'm smarter because I have a master's and he doesn't. Okay, so moving on. No. Okay, so the next thing is coterminal. I kind of hit on this when I was graphing the 500 degree. So when I had to go over more than once, I had to go back around and add 360 to each of my numbers. So notice for the 3 I did label, each of them, the 2 numbers are different by 360 degrees. Okay? So for number 4, it wants me to find a positive and a negative angle that match up. So for my positive angle, I'm just going to add, I can spell positive. Yeah, negative 45 plus 360, which gives me 315. And that's my positive angle. For my negative, what am I going to do? Yep, subtract 360. So negative 45 minus 360 is negative 405.
Negative 405?
Yep, because they're both negatives. So questions on number 4. A complete circle is 360. So if I start somewhere and then I spin around in a complete circle, I'll end up in the same spot. So when it asks for coterminal angles, it means for something that ends in the same spot. Any other questions? Okay, what? you add, if it's positive, you add 360. If it's negative, you subtract 360. It's always 360. Okay? So, what do you guys want me to do for the positive on 5? So I have to use 395, but adding or subtracting? Okay. 395 plus 360 is 755. Okay, then for my negative 1, I'm going to do... Is that a negative number, Jerry? Yeah, so I subtract 360 and Jerry said 35. Is this... Oh, that's off the screen. Is that a negative number? So I have to subtract again to make it negative. So I'm going to do this time 35 minus 360. Negative. Questions here? You're always going to subtract 360, and if it's wanting a negative number, I subtract until the number's negative. Yeah. So questions there? Okay. Then the next thing I need to go over is converting between radians and degrees. This you did learn in geometry. I'm sure of this one. Wow, that's cool. So to turn degrees into radians, I multiply by pi over 180. And to turn radians to degrees, I multiply by 180 over pi. So on number 6, it wants me to turn it into radians, because it's already degrees. So I'm going to multiply by pi over 180. So basically, I just need to remember that half a circle is either pi or 180. And then depending on what I have on top, if I have degrees on top originally, then I want degrees on the bottom. So to do this, what I'm really going to do is I'm going to rewrite this as 120 divided by 180, which is... Okay, so this gives me a decimal. When I work with radians, typically I want them as fractions. Remember to turn a decimal on the calculator into a fraction. I go to math, and then the first choice is FRAC, stands for fraction. I press enter. I press enter one more time, and it gives me 2/3 off the screen. Yeah. And then I turn my answer back into a fraction so I can write it. Yeah. Yeah, I have to keep my pi. So questions there? Okay. So the other one is starting off in radians. This time I want to turn it into degrees. So because it starts in radians, I'm going to have the pi on the bottom. You learned this last year in geometry. Remember how the radius, you know what a radius of a circle is, right? So when you go to map the radius on the circumference of the circle, there's 6.28. It goes around 6.28 times. And so basically a radian is 1/2 of the circle. Does that make sense? Okay. So on number 7, what I want to do is I have a pi on the top and bottom. I'm going to start off by crossing those out. So I'm going to rewrite this. I have negative 180 over 12. Negative 180 divided by 12 gives me negative 15. So since I went from radians to degrees, I have to remember my degree symbol. Questions on number 7? Okay, then after this, there's one more thing I need to teach you. Yeah. This pen is like dying and I don't know why. It's a brand new one. Can I move on to number 8? Oh. No, it's the multiplication x. Any other questions? Can I move on to 8? Okay, So number 8 is talking about arc length. So kind of like what I was describing with the radians on the circle, I want to see the length of part of the outside of the circle. The formula for this one is S equals R pi. I'm just kidding, that's a theta. So what I'm going to do is, if I take a look, sorry, this did not copy well. I want to take a look at this, is it softball field? I'm looking at a softball field. Oh, I know. I said today's was easy. Okay, so I want to figure out my sector length. The formula is R times theta. What's my radius on this picture? No, you got the angle. What? 200. Sector length or arc length. And then my theta, my degree, 90. So what I'm going to do is I'm going to multiply by my degree. Wait, just kidding. I don't want to do 90. I want to do it as radians. Radians. So remember on the 6 and 7, when we were turning it to the numbers with the pi? So what I'm going to do is I'm going to do 90 times pi over 180. Which gives me pi over... Try again, Jerry. Yeah. Yeah. Yeah, 1/2. So, pi halves is what I wanted in here. Yeah, it stays with pi. Anytime it's 1, I don't have to write the number. Okay, and then over here, I have 200 times pi halves. So it's the same thing as if I did 200 divided by 2 times pi. Yeah, because I can move the bottom of the fraction to either one. No, just 100 pi, Jerry. Yeah. Yeah. Any other questions? Yeah, when it's doing the sector length or arc length, you want to turn it back into radians. I was so used, I don't know, it's like one of those days, like, I'm still not back to being like in teaching mode, you know, because of AZ Merit. Yeah, but here we are.
But why is it blurry?
Yeah, no, I froze it blurry. There you go. Any other questions?